This is the communication monitoring long-term deformation processes in JEP, the Canary Island case, from Instituto Geográfico Nacional and Universidad Complutense de Madrid. Long-term deformation processes can play an important role in volcano deformation monitoring. It is essential to get long-time series in order to be able to discriminate real deformations. INSAR's vast methodologies are suitable to detect moving areas in natural environments. EAR's ENVISAT and Sentinel catalogs allow to obtain displacements time series in 1992. Applying SVAS over historical datasets involves large amounts of storage and high processing capacity. Cloud computing platforms can be suitable to detect long-time deformation processes. We use JEP and GPOT to process ENVISAT and Sentinel historical datasets over Tenerife and Lanzarote Islands in order to validate results in already known deformation areas, study temporal and spatial evolution of the deformations, and create vertical and horizontal displacements average time series of deforming areas. Those are the historical eruptions which took place in Tenerife and Lanzarote. And we also show the datasets and processing strategies to obtain velocity displacements in the islands. Those are the results for Tenerife deformation called TIO. We have processed ENVISAT descending and ascending tracks over the area, and we have obtained average vertical and horizontal displacement time series. We also try to do the same with Sentinel descending and ascending tracks, but we found that ascending track had residual atmospheric signals that we couldn't eliminate properly. So we used only the descending track. What we have found is that there are negative vertical displacements in the area with an average velocity of between 6 and 7 millimeters per year. We did the same study for Garachico deformation in Tenerife, and we obtained also negative vertical displacements in the area with an average velocity between 6 and 7 millimeters per year. The same study was made for Izaña, finding an average velocity of 8 millimeters per year, also with negative trends. In Teide Pico Viejo, we tried to do the same study, but we didn't find clear displacements with the descending ENVISAT track that we used, and the ascending track did not cover the area properly. So results are based only on one track from Sentinel, the descending one, and we have found that the area is experimenting a loss lengthening, which means movement in the down and west components, and with an average velocity of 8 millimeters per year. We also calculate results for Timanfaya area in Lanzarote Island using two tracks for ENVISAT and in this case two tracks also for Sentinel, and we found vertical velocity decreased from the ENVISAT period compared with the Sentinel period in a range from 4.5 centimeters per year to 2, and we also found spatial changes in the displacement pattern in the area. This table shows some of the conclusions of the work. Although we haven't used EAR's ENVISAT to calculate displacement in this work, some authors did in the past, and what we have found is that the displacement found in this, compared with those articles, are similar in magnitude and also in directions as the ones we have found. So we can say, taking into account this fact, we can state that accumulated deformation is what we show in the table in an approximate way. TIO, Garachico, and Izaña subsidence can be related with natural consolidation. Teide Pico Viejo displacements agree with downslope directions. Timanfaya displacement pattern has changed with time and could be pointed to interaction between aquifers and the volcanic system. We consider that JEP and GPOT SVAS methodology is validated in our case, So we plan to calculate time series displacements and velocities for every island in the archipelago using all images available for Earth, Envisat and Sentinel. We especially thank TerraDue and ESA network of resources for providing access to JEP, and we would like to acknowledge ESA Research and Service Support for their assistance in processing the data with GPOT. If you want more information, you can contact me, and thanks for your attention.